Hello guys, so we are back again, and in this session we are going to start with a new topic, which is Lagrange method of undetermined variable. So before beginning with the session, I want to tell you to subscribe the channel so that we can bring more engineering content for you guys. And in the previous session we have completed our first derivative test and second derivative test for finding maxima and minima of a function at a given point. So let's write the topic: Lagrange method of undetermined variables. So this is our second topic, which is the last topic of maxima and minima, which you will see in engineering mathematics 1. So what this method tells, okay, we are not going to do the derivation, okay, it is of no use in the question. What actually will be useful, I am going to tell you. And these derivations, the Lagrange derivation is never asked only in examination, so if you're doing, you're probably wasting your time. So what actually the content involved in Lagrange method of undetermined variables? So here they will give you a function f of x, y, z, or f of x, y. What you have to do, you have to find the points where it attains maxima and minima. Now you should have a doubt that, sir, we used to do the same thing in the first derivative test and second derivative test. Yeah, but here the difference is you will be given a constraint equation. Constraint equation are are generally implicit equations. Implicit functions where what type of function? F of x, y, z equals to 0. This type of function, they used to be what? Implicit function. We have discussed in partial derivatives in detail what are implicit function. So here the point which you are checking maxima and minima should satisfy this constraint equation or implicit function, which they will give you in the question. That's it. And then you have to make a Lagrange function and its structure, and this constraint equation or whatever this, it is denoted by phi x y z or phi x comma y, depending upon how many variables they are given in the question. So the Lagrange function which you will consider is always L equals to f of x comma y plus lambda times phi x comma y. Just keep this in mind, it is very important equation. If you forget this, you are going to fail. Okay, you have to skip this question in examination. It's very confirmed, because if you don't know to form the Lagrange function, which is L equals to f of x comma y plus lambda phi x comma y, then you will not be able to solve the question. So just learn this. Now you have to get stationary points. How you will get stationary points? By solving dou L by dou x, dou L by dou y, dou L by dou z if z is there, a variable, and dou L by dou lambda equal to 0. All are equal to 0. You have to solve them and get the x and y, and then you have to substitute in f of x comma y to check whether it attains maxima minima. So this is the Lagrange method of undetermined variables, and this is all the things which are involved in these type of questions. So we are going to probably move to the question part, because the theory is not that much involved here and derivation is just of no importance. So let's move with the questions. So the first question which we are going to encounter in this is this question: find the maximum and minimum value of the function f of x comma y equals to 3x plus 4y on the circle x square plus y square equals to 1 using the method of Lagrange multipliers. Now here, whenever they tell you to maximize or minimize a function, it is nothing but your f of x comma y. Okay, even though they have not mentioned it x comma y, we would have been known that we have to consider it x comma y. And whenever they give you equation like x square plus y square equal to 1, you can directly make out that if I move this one here, it will become equal to 0, which is a property of implicit function that f of x comma y is equals to 0. So this is probably my what, phi x comma y, right? So how I am going to proceed this question? First, I should know f of, what is my f of x comma y? It is 3x plus 4y. So let phi x comma, because phi they have not mentioned, so we have to consider it phi x square plus y square minus 1. Okay, then only it will become equal to 0. Now we want to do what? Consider the Lagrange function, which is, as I mentioned, because if you don't know Lagrange function consideration, then you have to leave this question. Okay, so consider the Lagrange function. What was the formula to consider it? It was L equals to f of x comma y. See, since here x comma y are the two variables, lambda times phi x comma y. Now we are going to substitute the values, 3x plus 4y plus lambda times x square plus y square minus 1. I am going to give it 1. Now stationary points, as I mentioned, the next job is to get to the stationary point. Stationary points are obtained by solving what I have mentioned in the explanation. Dou L by dou x equals to 0, dou L by dou y equals to, do I need to write dou L by dou z? No, here the function is in x and y only, so we will write dou L by dou x, dou L by dou y, and dou L by dou lambda equal to 0. First we will consider this should be equal to 0. So first dou L by dou x will be what? If I differentiate it with respect to x, 3 plus lambda times 2x, it should be equal to 0. And if I simplify it, I am going to get x equals to minus 3 by 2 lambda, which is my second equation. Let me consider the next page. So if I consider the next page, what I can see, what is my next thing is dou L by dou y, which is nothing but if I differentiate it, 4 plus lambda times 2y equals to 0, and from here I can get y equals to minus 4 by 2 lambda, which is my third equation. Now I need to get dou L by dou lambda, which is nothing but, now here observe, if I differentiate this with respect to lambda, this will become 0, and here this thing whole will remain as only. Okay, so what I am going to write here, x square plus y square minus 1 should be equal to 0. Simple. After writing this, what is my job? Put x and y from 2 and 3, then we will get lambda value. So if I substitute, I am going to get 9 by 4 lambda square plus 16 by 4 lambda square minus 1 should be equal to 0, giving me 9 plus 16 minus 4 lambda square equals to 0. If I multiply throughout by 4 lambda square, then I am going to get 25 equals to 4 lambda square, giving me lambda equals to nothing but plus minus 5 by 2. If I get my lambda plus minus 5 by 2, when lambda equals to 5 by 2, right, then from this equation, this from 2, I can write x equals to, you have to mention it from 2, minus 3 by 2 into lambda, which is 5 by 2. I have considered the positive one, so my answer is minus 3 by 5. And y is nothing but, from here you can directly make out minus 4 by 2 into 5 by 2. Here negative will be there, minus 4 by 5. And when lambda equals to minus 5 by 2, what I am going to get, then x will be nothing but minus 3 by 2 into minus 5 by 2, right, which will be 3 by 5. And similarly y will be, I can directly write here minus sign will be there, so 4 by 5. You have to solve it and show the teacher. Let me get to the next page. So what we can see is that we got the stationary points. So the stationary points are what? Minus 3 comma 5, minus 4 comma 5, 3 comma 5, 4 comma 5. Therefore what we can write? Stationary points are, what are the stationary? minus 3 by 5, minus 4 by 5, and 3 by 5 comma 4 by 5. So now we want to know the maximum and minimum value, and these points satisfy this constraint, which was, what was the constraint? phi x comma y, because we got it by solving dou L by dou x, dou L by dou y, and dou L by dou lambda. So f of 3 by 5 comma 4 by 5, we are going to substitute it in this function. If I substitute, what I am going to get? 3 into 3 by 5 plus 4 into 4 by 5, which is nothing but we will get 9 by 16 upon 5, which is nothing but 25 by 5, giving me final answer 5. And if we see f of minus 3 by 5 comma minus 4 by 5, which is going to give me, here just minus sign will be there, so minus 5, which you can calculate. Therefore you can say maximum value of f of x comma y is 5, and minimum value of f of x comma y is minus 5. So we are done with this problem. Hope you have understand each and every step. What we have to do, this is the general process to solve any type of Lagrange method type questions. They will give you a constraint, they will give you f of x, which you need to identify by implicit function and by the given data. Now let's move on to the next question. So the next question which we are going to take is, where is the next question? So the next question is this question. The next question says, find the maximum value of f of x comma y equals to x square plus y square subjected to x plus y equals to 2 using Lagrange method. Now they have given you f of x, so it is very easy for you to know that what we have to take f of x comma y and phi x comma y. So f x comma y they have given x square plus y square. In the next step, let phi x comma y is equals to x plus y. We will move this 2 here, which is minus 2, equal to 0. Now our next job is to consider the Lagrange function. What is the Lagrange function? How we consider it? It is L equals to f of two variables are involved, f of x comma y, lambda times phi x comma y. We are going to substitute the things, which is x square plus y square plus lambda times this thing x plus y minus 2. This is our L. Now stationary points are obtained by solving what? Dou L by dou x equals to 0, dou L by dou y equals to 0, and here z is not involved, so I am not going to take z. Dou L by dou lambda equal to 0. Consider this one. Dou L by dou x is nothing but 2x plus lambda, which should be equal to 0. Can I get my x value? Yes, x equals to minus lambda by 2, which is our I will call this one as my first equation and this one is my second equation. Similar, dou L by dou y equals to 2y plus lambda equal to 0. Therefore y equals to minus lambda by 2, which is third equation. So dou L by dou lambda, which is nothing but, here this whole thing will be left, x plus y minus 2. So here this thing should be equal to 0. So we are going to substitute the x and y value from 2 and 3. So if we substitute, put x and y value from 2 and 3. If I substitute the y value from x and y value from 2 and 3 in dou L by dou lambda, what I am going to get is nothing but, if I substitute minus lambda by 2 into minus lambda by 2, since both them are equal, into minus 2 should be equal to 0, this will become minus lambda, minus 2 should be equal to 0. I am getting lambda equals to minus 2. So when I'm going to do it here, when lambda equals to minus 2, so x equals to minus lambda by 2, which is nothing but 1, and y equals to minus lambda by 2, again it is equal to 1. So stationary, therefore stationary point is 1 comma 1, right? Now therefore f of 1 comma 1 is nothing but f of 1 comma 1, we will get it from here, 1 square plus 1 square is nothing but 2. Therefore maximum value of function is 2. So we got the maximum value of the function, because since there was only one stationary point possible, so either it will be maximum or minimum, whatever they tell. If two stationary points were again, then we could decide what is maximum and what is minimum. So in this session we are going to wind up the things here. We studied the things about Lagrange method of undetermined variables, and we studied the how to consider the Lagrange equation, which is L equals to f of x comma y plus phi f of x comma y, or L equals to f of x comma y comma z plus lambda times phi x comma y comma z. Lambda is there, okay, lambda phi x comma y comma z. So that was important, how we solve, find f of x, find phi x comma y, which is mostly implicit function. They can directly give you, like in these two questions they directly give you, but they might hide it, and you must have to predict it by knowing the implicit function properties or by reading the question. Second, you need to consider the Lagrange theorem. Stationary point, you have to obtain the stationary point by solving dou L by dou x, dou L by dou y, dou L by dou z, and dou L by dou lambda. Here z was not present, it was the function in terms of x and y, so we solved dou L by dou x and dou L by dou y. Further, you will get some lambda value. In dou L by dou lambda, you have to substitute x and y value and get stationary points. After stationary points, you have to put it in the function f of x comma y, f of x comma y z, whatever it is, and you will get your required answer. Thank you. See you in the next lecture.